Good day to all of you. Myself, Savant Ajay Bhaskar, working as an assistant professor in Shiv Shankar College of Agriculture Engineering, Mirasgaon. Now, today we will discuss on topic that's belt drive and their design steps. Number first, here is a belt. I have shown the how the belt power is to be transmitted from tractor PTO to the another working mechanism. Belt is a flexible mechanical element that transmit power from one shaft to another. Means of power transmission: gear train, example automobile engine etc. Chain drive, example bicycle, motorcycle etc. For belt drive, rice mills, sewing machine etc. Rope drive, lift and crane etc. Belt drive and power transmission: amount of power transmitted by belt depends upon following things: velocity of belt, tension of the belt, arc of contact between belt and smaller pulley, condition under which the belt is used. Belt drive selection criteria: speed of driving and driven shaft, power to be transmitted, positive drive requirements, space available, speed reduction ratio, center distance between the shafts, shaft layout, and service conditions. Belt type: here is I have shown the various types of belt: flat belt, V belt, and circular belt. The shape of circular belt is circular. V belt is actually looking triangular type, but is actually is trapezoidal section, and flat belt it should be the flat. And the below section round belt, V belt, I have shown the actual image of that type. Belt material: the material used for constructing the belt material as leather belt, cotton or fabric belts, rubber belts, balata belts, similar to rubber belt except that balata gum is used in place of rubber. Belt drive type: open belt drive and closed belt drive. There are two types of drive. The open belt drive is used with shaft arranged parallel and rotating in same direction. See here by using diagram I have shown the A and B. These are the two pulleys. Driver is rotating in clockwise direction and driven member is rotating in also in clockwise direction. In cross belt drive, the cross belt drive is used with shaft arranged parallel and rotating in opposite direction. That means drive member and driven both are rotating in opposite direction. Upper section is slack side and below section is tight side. Belt drive type: belt drive with idler pulley is used with shafts arranged parallel and when belt drive cannot be used due to small angle of contact on smaller pulley. Idler pulley is a pulley which does not transmit power but assists power transmission by increasing angle of contact of smaller pulley. Belt drive type: compound belt drive. A compound belt drive as shown in figure below is used when power is transmitted from one shaft to another through number of pulley. Here is given the example of belt drive: driver member, driven member, and another one belt is also attached, that is driven member and driven member. Belt drive type: stopped and cone pulley drive is used for changing the speed of driven shaft while main shaft runs at a constant speed. Fast and loose pulley drive: fast pulley keyed to the driven shaft; loose pulley not keyed to driven shaft. It can freely rotate when needed. Belt side over to loose pulley. This driven shaft can be stopped without stopping drive shaft. Length of belt can be calculated by using this formula: pi into bracket r1 plus r2 plus 2x plus r1 minus r2 whole bracket square divided by x. That is alpha is for angle of contact, r1 minus r2 divided by x. Length of belt: length of for cross belt drive is equal to pi into r1 plus r2 plus 2x plus r1 plus r2 bracket square divided by x. Angle of contact, that is alpha, is equal to r1 plus r2 divided by x. Ratio of driving tension for flat bolt: consider a driven pulley rotating in clockwise direction. Here is shown: T1 is a tension in belt on tight side, T2 is a tension in belt on slack side. Theta is the angle of contact in radians, that is angle subtended by arc AB along which the belt touches the pulley at center. Now consider a small portion of belt PQ substituting an angle d theta at the center of pulley as shown in figure. The belt PQ is in equilibrium under following forces: tension T in belt at P, tension T plus delta T in the belt at Q. normal reaction Rn, frictional forces F is equal to mu plus Rn, where mu is the coefficient of friction between the belt and pulley. Ratio of driving tension for flat belt, resolving all forces horizontally and equating the same. Rn is equal to, you will get the equation t plus dt into sine d theta divided by 2 plus t into sine d theta by 2. This one is equation number first. Since the angle d theta is a very small, therefore putting the sine d theta by 2 is equal to d theta by 2 in equation first, then you will get the equation that is Rn is equal to t into d theta. If you further modify this equation, now resolving the forces vertically, you get the equation that is mu plus Rn is equal to t plus d theta plus cos into d theta by 2 minus t into cos d theta by 2. Further modifying d theta is very small, then you will get the final equation mu into Rn is equal to t plus dt minus t is equal to delta t plus, or Rn is equal to delta t divided by mu. Ratio of driving tension for flat belt, then equating this both the equation second and fourth, you will get the value t into d theta is equal to mu into d theta. Integrating both the sides between the limit t2 and t1 from 0 to infinity respectively, you will get the final equation that is 2 into log t1 by t2 is equal to mu theta. The above expression gives the relationship between tight side and slack side tension. In terms of coefficients of friction and angle of contact, centrifugal tension, since belt continuously runs over the pulley, therefore some centrifugal forces is caused whose effect is to increase the tension on both tight slack side. This tension caused by centrifugal force is called centrifugal tension. Centrifugal tension derivation, this equation is used. M is the mass of belt per unit length in kg, V is the linear velocity, R is the radius of pulley, Tc is the centrifugal tension acting tangentially. We know the length of belt Pq is equal to R into d theta, and mass of belt Pq is equal to M into R into d theta. Due to mass we are adding M. Centrifugal force acting on belt Pq is equal to Fc is equal to M into R into d theta multiplied by V square divided by R is equal to final equation modifying, you will get M into d theta into V square. Centrifugal tension Tc acting tangentially at P and Q keeps the belt in equilibrium position. Now resolving the forces, centrifugal force and centrifugal tension horizontally and equating the same, we have get the final equation that is M into d theta into V square. Since the angle d theta is very small, we know, therefore putting the sine d theta by 2 is equal to d theta by 2 in the above expression, so we will get the equation that is M into V square, that is Tc. Note, when the centrifugal tension is taken into account, the total tension in the tight side T in small t1 is equal to t1 plus tc. Total tension in slack side is equal to t into small t2 is equal to t2 plus tc. Power transmitted P is equal to t1 minus t2 into V. This one is the further equation. So the ratio of driving tension may also be written as 2 into 3 2.3 log in bracket t1 minus tc divided by t2 minus tc is equal to mu theta. T1 maximum or total tension in the belt. Relationship between maximum tension and strength of belt. A little consideration will show that maximum tension in belt is T is equal to total tension in the tight side of belt is Tt1. We know that the maximum tension in belt is equal to sigma into B into T. When centrifugal tension is neglected, then we will get the value that is T is equal to T1, and when centrifugal tension is considered, then value T is equal to T1 plus Tc. Thank you, friend.